Okay, everybody. So what we're going to be looking at today is going to be the practice exam number 1. So if you look on the course Canvas page, you'll find exam 1 information, which I just clicked on. And under that, you'll find the practice exam PDF. Now, under that, you can see where it says practice exam solutions and practice exam video. That's what we're making right now. So they're not there yet. Do pay attention to the what you can use on the exam section. The exam is closed notes, closed book, but you can have a calculator on the exam, and you can have a cheat sheet, which is the front side, so one side of a half sheet of paper. That's what you can have for writing whatever you want on it to take to the exam. Okay, let's go ahead and get started working on those notes. Notes, solutions. All right, so here we go. So this is the practice test, and I am just going to go through it and solve these problems one by one. Okay, so let's just start at the beginning. I think there's 16 problems. They go from section 2.1 up to 2.7, and they're basically in order that they are in the book. So like when we start out, these problems right here, these are from section 2.1. So let's just go ahead and get right into it. So the first problem says to find the x and the y-intercepts of the lines. So if you're looking at a set of axes, you know that the x-intercept is where the line intersects the x-axis, and the y-intercept is where the line intersects the y-axis. However, we don't know where those points are, so I shouldn't have drawn them as dots on this graph. So let's find them. So in order to find the x-intercept is going to be where the y value is 0. So where y equals 0. So you take this equation right here, 4x plus 2y equals 16, and you plug in y equals 0. So 4x plus 2y, but y is 0, equals 16. Well, 2 times 0 is 0, so this is going to be gone. And then you have 4x equals 16. Then you divide both sides by 4, and you get x equals 4, right? So that was x equals 16 over 4, which is 4. So that's the x-intercept. So the x-intercept is the point x equals 4. I don't know why I just wrote x. X equals 4, y equals 0. We know that the y is 0 because y is 0 for the x-intercept by definition. So this is your x-intercept. Now to get the y-intercept, you do exactly the same thing we just did, but for the y-intercept, you want x to be 0. So x equals 0. So you go back to this original equation and you plug in x equals 0. So 4 times x, which is 0, plus 2y equals 16. So 2y equals 16. So y equals 8 when you divide by 2. So that tells you that the y-intercept, the y value is 8. We just found that. And of course, the x value is 0 by definition. So your solutions here are right here, the x-intercept and the y-intercept. Now, it doesn't say to draw these on a graph, but if you did, then it would be 1, 2, 3, 4. There's 4, 0. And 0, 8 would be 8 up on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. 0, 8. And if you just connect these lines, if you connect the dots with a line, I didn't do that particularly well, that would be your line, the line 4x plus 2y equals 16. Okay, and that's how you do it. Now, for the second problem, y equals 3x plus 4, that's actually a little bit different. I mean, it is and it isn't. So this is already written in slope-intercept form. And whenever you have y equals mx plus b, that slope-intercept form, the b is automatically the y-intercept. So I can just look at this right here and I can just say that the y-intercept is going to be y equals 6. And of course, for the y-intercept, that's where x equals 0. So it would be 0, 6. So 1, 2, 3, 4, 5, 6. So there's your y-intercept. Now, you don't have to worry about just knowing that. You can do this one exactly the way you did the previous problem as well, right? So for the y-intercept, you know that x is 0. And then y equals 3 times 0 plus 6. And of course, 3 times 0 is 0, so this is just 6. So you get there no matter what. Either you know that it's just the 6, or you do this one step, and then you find out that it's 6. Then you do the same thing for the x-intercept that we did for the previous problem. So for the x-intercept, we know that y should be 0. So you have 0 equals 3x plus 6. Going back to this original equation, and then you solve for x. So you subtract 6, negative 6 equals 3x. Divide both sides by 3, and x is negative 2. So what we've got then is your y-intercept, which we found first, was 0, 6, and your x-intercept, which we just found, was x equals minus 2, and of course the y value is 0. So if you plot that, 1, 2, be right there, negative 2, 0. And of course, if you want to graph your line, you can. Something like that. But the solution to the actual problem is right there in the box. Okay, you don't need the graph here. And that is how you find the intercepts. Going on to problem 2, we need to graph a line. Well, you can graph the line. I mean, we just graphed 2 lines actually, right? So you can do this one exactly the same way by finding the intercepts. Rather than finding the intercepts, I'm going to use the slope and the intercept here. So whenever you have y equals mx plus b, the m is the slope and the b is the y-intercept. So if I've got our equation here, which is y equals 2/5 x minus 3, the slope is 2/5, and the y-intercept is y equals minus 3. Okay, so with that information, if we want to plot it using this information, we'll start with the y-intercept, y equals minus 3. So that is right here, right? Minus 3 on the y-axis. So we plot that. And then for the slope, so this is the first thing we use. And then for the slope, m equals 2/5 means rise over run is 2/5. So that means the rise is 2 and the run is 5. So that means up to, I didn't write up to. So rise over run equals 2/5 means go up to, go right 5 from the point that we've got plotted here. So if we went up 2, we'd be at -1, and then you go over 5, and you'd be right here. So this is your next point on the graph, which it looks like -1 comma, no it doesn't. Looks like 5 comma -1. This one was 0 comma -3. Anyway, once you have 2 points on the graph, then you just connect the dots. Didn't do a very good job. That's better. And there's my line. Okay, so I plotted that using the slope and the intercept. You could also plot it exactly the way we did these, where you have the Y-intercept and the X-intercept. Okay, so that was, we graphed 3 lines actually, but that was good enough. All right, midpoint of a line segment. So midpoint of a line segment in general, right? Just to make sure we know what we're talking about. You've got a point here, let's say x1, y1. You've got another point somewhere else, x2 comma y2. And if you think about just kind of connecting the dots here between them, there's some point that's exactly in between, right? And that's the midpoint. And there's a formula for it, and the formula is given right here. So all you have to do is make use of this formula. So you look at the points that they gave you, 2 comma 3, and say that's x1, y1. The other one will be x2, y2. And you basically just fill in the numbers in this formula. So our midpoint is simply going to be x1 plus x2, so that's 2 plus minus 4 over 2, comma, y1 plus y2, which is 3 plus 7 over 2. And then you just simplify that. Use a calculator or do it by hand. So 2 minus 4 is going to be -2 over 2. 3 plus 7 is going to be 10 over 2. And then I see that that's going to be -1 comma 5. And that is my midpoint. Just looking at it for a second, yeah, that looks right. So there we go. So we're just using the formula, and that's it. On to the next problem. So now we're finding the distance between 2 points. Now we've got a formula here for doing that. Of course, I will try to explain what's going on, but you've got 2 points here, x2, y2, x1, y1, similar to the previous problem, but this time what we're doing is if you connect those with a line segment, the question is, well, what is this distance? And the way you calculate it is with this formula right here, which comes from the Pythagorean theorem. Because you can take this line segment and you can kind of draw a triangle on it. And if you use the Pythagorean theorem on that right triangle, it results in this equation. You don't have to know that, you just have to use this formula. So we jump straight to the formula here. And we say, well, D is going to be, well, what is it? Well, we need to know our points. So we have x1, y1, x2, y2. And just like the previous problem, you just fill in the numbers. So we've got square root. That's not a square root. That's also not what I wanted. Okay, I think this is better. Nope, still worse. Okay. So fill in the numbers. So we have x2, which is 5, minus x1, which is -2 square, plus y2, which is 3, minus y1, which is 4 squared. Work out these numbers. So we've got 5 minus -2, which is going to be 7 squared, plus 3 minus 4, which is -1 squared. 7 squared is 49. -1 squared is +1. A big mistake people make on these is somehow this negative ends up outside here because people forget to write their parentheses and they end up with a minus sign like that, and that ruins things. So be careful with your minus signs. So this is a square root of 50, it looks like, if I didn't make any mistakes. And that's your answer. That's good enough for the answer, by the way. Just leave it like that. If you want to simplify this, you can go further and you can say that square root of 50, well, 50 is 25 times 2. So this is square root 25 times square root 2. Square root 25 is 5. And you can write it like that. Also, many calculators will simplify this. So if you have a calculator like the ones that I recommend, then when you type in square root 50, the output will be 5 square root 2. So you don't have to simplify it, but you can. And that is the distance. All right, next problems. So what we've got now are a couple of problems where we're just solving equations. I think this is section 2.2. It could be like a little bit later, 2.3, something like that. But regardless, we're just going to solve these. So these are very straightforward, just kind of a test of basic algebra. So if we're going to solve for x on this first equation, 2x plus 1 equals -9, we want to get the 2x by itself. So we want to get rid of that plus 1. So we subtract 1 from both sides. Of course, it cancels on the left and we get 2x. On the right, -9 minus 1 is -10. Don't know why I can't write. There we go. Then what you want to do to solve for x is divide by 2. So divide by 2, divide by 2, and we end up with x equals -10 divided by 2, which is -5. There you go. That's all there is to that. Now, as we move on, we've got another problem that's similar, but on the next problem, you can see that it's just more complicated, right? There's just more stuff here. So my advice for this is if there are parentheses, right, like this, multiply that out first, right? Just multiply out any parentheses. That will save you some trouble. So if we multiply that out, we have to distribute this 2. So 2 times x is going to be 2x. 2 times 1 is going to be plus 2 equals 5x minus 9. Plus 9. Sorry. Okay. So once you get your parentheses cleared out, you need your x's on one side of the equation. It doesn't matter if they go to the right or they go to the left. They just need to be on one side. So I'm going to move them to the right. So what I mean by that is I'm going to subtract 2x from both sides. Of course, over here they cancel, which is the point. And we end up with 2 equals 5x minus 2x is going to be 3x plus 9. So already it's looking a little better. Then we want to move the 9 to the other side. So subtract 9, subtract 9. So we end up with 2 minus 9 is -7 equals 3x. And then finally, to solve for x, we should divide both sides by 3. And we end up with x equals -7 over 3. And you don't need to simplify that or anything. Don't need a decimal approximation. Just leave it like that as a fraction. Okay, so we are moving right along. So as we go, the problems are getting a little more complicated. For these word problems that we're about to do, please remember what I said in class. that the word problems are going to be like one of these problems. So your word problems will be like one of these. So take the time to understand these pretty well. Okay, so this first one right here, it talks about the perimeter of a rectangular patio, right? So we know that for a rectangle, you've got two dimensions, a length and a width. So let's call this one length and this one width. But if you do that, then of course, if the left side is L, the right side is L. And if the bottom is W, the top is W, right? So the perimeter is 2W plus 2L. So you have to know this. Perimeter of a rectangle. I may give it to you, but I may not. So know the perimeter of a rectangle. And then you have to be able to translate statements like this one. The length is 3 feet greater than the width. So you need to read that and understand that what this is saying is that the length, which is L, is 3 feet greater than the width. So 3 feet greater than the width means W plus 3. 3 feet greater than the width. Okay? Then what you want to do is you want to use this fact that the perimeter is 54. So we take this perimeter equation, P equals 2W plus 2L, and we're going to rewrite it. We're going to rewrite it using this, first of all, 54 feet for the perimeter. So you put 54 feet for the perimeter. Then you've got 2W. 2W is just going to be 2W. 2W plus. Then you've got 2L. 2L. But we have this equation right here telling us that L is actually W plus 3. So you replace L with W plus 3. Like that. And this is an equation to solve. Now solve it. Now you're going to solve this exactly the way you solved the equations up here. So we just need to multiply it out. So 54 equals 2W plus, here you have to distribute the 2. So we end up with 2W, and 2 times 3 is going to be 6. So we're here. We can combine the 2W and the 2W. So we have 54 equals 4W plus 6. We should subtract 6 from both sides. We end up with 48 equals 4W. And then we should divide by 4 to solve for W. We end up with 48 over 4 is 12, and that's W. So we have W equals 12. Now notice this problem asks for the dimensions. That means you need the L and you need the W. Right now we've only got W. So we still have to find the L, which we can do because we have an equation right here that tells us how to calculate L if you know W. So we know that L is W plus 3, but we know that from down here, W is 12. So you go L is 12 plus 3, and L is 15. There. So if you want to write your answer a little bit nicer, what you can say is that the dimensions are, well, they're going to be in feet, right? Because we're talking about 54 feet and 3 feet. So our width is 12 feet and our length is 15 feet. And that's it. Those are the dimensions. So you should know how to solve one of these perimeter problems. You're not guaranteed to have it, but you might. Number 8. So distance equals rate times time. Distance equals rate times time, or as an equation, d equals rt. And then we need to use that equation. So we have this equation that's given to us. Distance equals rate times time. Distance, rate, time. And so any of these problems, the way they're going to work is they're going to tell you 2 out of the 3 of these things. Right? So we're given 2 out of the 3 variables. Right? You just have to figure out which ones they are. So find the distance. So if we're being asked to find the distance, then we don't know the distance. But we know the other 2. So it says he's moving at a rate of 55 miles per hour. So that's r equals 55. And you can write the units, miles per hour, if you want. And then we've got 3.5 hours. That is a time, right? 3.5 hours is a time. So that's t. 3. And we're missing the distance. We don't know it, right? So do you see how this is? We know 2 of these, but we don't know the third one. So you go back to your equation here, d equals rt, and you fill in the 2 that you know. So d is what we don't know, but we know that the rate is 55, and you can write that miles per hour if you want. And we know the time is 3.5 hours. If you work out the units, the hours will cancel, but you could just leave the units off for when you're doing this calculation, and that'll be okay as well. And what we'll get here is d is 55 times 3.5. So yeah, so this is where the first time I'm going to need a calculator. I just realized I left mine on the other side of the room, so it will be silent for a minute as I get up. I can't pause this video, so this is how it has to be. All right, so let's see where we are. So we've got 55 times 3.5, so 55 times 3.5, just punching that into a calculator. My calculator says 385 over 2, but I can hit a button and get a decimal. So 192.5. And that will be in miles, because that's the distance. So these problems look harder than they are, I think. Certainly they can be harder than this, but this one was okay. So now we're getting into solving quadratics. Now, notice that I've always, on all of these, I suggest a method like factoring, but I don't require you to factor. So if you're really good at the quadratic formula, feel free to use that on every problem if you want. Yeah, I'll just use the method that I recommend. So let's go ahead and get started. So we've got this here. We have an equation to solve, not just factoring. So the way we'll solve this when the leading coefficient is a 1 is I write a little x like this. I put the c, which is 15, up here. I put the b, which is 8, down here. We look for numbers that multiply to the 15 and add up to 8. So if you think about it for a little bit, you'll figure out that 3 and 5 are correct. Right? 3 plus 5 is 8. 3 times 5 is 15. So you find those two numbers. And that means that our equation, which is x squared plus 8x plus 15 equals 0, we take the 3 and the 5, and that's going to factor into plus 3, x plus 5 equals 0. So that's factoring. So that worked okay. And then if you're trying to solve this quadratic, what you have to do after you factor is each of these factors is separately going to be equal to 0 to give you an answer. So this implies that x plus 3 is 0, or x plus 5 is 0. And then you solve these individually as if they were their own equations. So subtract 3 from both sides on that first one, and you end up with x equals minus 3. On the other one, subtract 5 from both sides, and you end up with x equals minus 5. So x is minus 3 or x is minus 5. Or, if you wanted to list them, the solutions are both of those. So let's box those solutions and we're done. The next problem is actually a mistake. It's just the same problem that we just solved. So we're not going to do that again. And onward. So for problem 11 here, it says the square root property would work well. Now, the reason the square root property would work well is notice that there's an x squared term and then constant. There's no x term, right? Like if you look at the previous problem, there's this 8x. And if you look at the problem we're doing here, there's no x term. And what that means is that you can just solve this with kind of pretty much regular algebra, not using any kind of factoring or anything. Let's go ahead and try it. So 9x squared plus 3 is 15. So we can just move that 3 over. Just subtract 3, subtract 3. We end up with 9x squared equals 12. And then we can divide both sides by 9 over 9 over 9. We end up with x squared is 12 over 9. Now, you should probably just reduce that fraction on a calculator or by hand. So 12 over 9 reduces because 3 goes into 9 3 times, 3 goes into 12 4 times. So what we've got is x squared equals 4/3. And then to solve this, the actual square root property that I mentioned right here means we want to just square root both sides to solve for x. So x is going to be plus or minus the square root of 4/3. And this right here is a perfectly fine answer. You don't have to simplify that further. This is fine. If you wanted to, what you could do is you could say square root of 4/3 is square root 4 over square root 3. The square root of 4 is 2. So you end up with 2 over the square root of 3. But as you may remember from other classes, you are supposed to rationalize the denominator if you have a square root in the denominator. So you can multiply by square root 3 over square root 3, and you end up with 2 square root 3 over 3. Now, that's more work than you probably want to do. Now, I can tell you that if I back up to this point, if I type in on my calculator square root 4/3, enter, it just instantly outputs this as the answer because my calculator knows how to simplify square roots. That's another reason why I recommend you have a calculator that can do that. But this answer is also perfectly acceptable. So don't do all this by hand if you don't have to. All right. And that's the square root property, was this step to this step. Right. Next question. Solve the quadratic by any method. And your choices here are quadratic formula or completing the square, pretty much. I'll do both maybe, just to show you. So let's do the quadratic formula first. So quadratic formula, if you remember, is x is going to be negative b plus or minus square root b squared minus 4ac over 2a. Good thing to write down if you don't remember it. And then we're going to fill in the numbers. Now from our equation right here, I can see that a is 1, b is minus 3, and c is minus 5. So if you fill those numbers into the quadratic formula, we get x equals negative 3 plus or minus square root negative 3 squared minus 4 times 1 times minus 5 over 2a, a is 1. Okay, so from here, what you want to do is just pretty much work out the stuff that is in the square root. So here, minus 3 is just 3. So 3 plus or minus. Inside the radical, we've got negative 3 squared, which is 9. And then minus 4 times 1 times 5. The minus will make that a plus. And then 4 times 1 times 5 is 20. So this is 20 over 2. So this is 3 plus or minus square root 29 over 2. And, yeah, that's it. So I would just stop here. I wouldn't simplify that further. I wouldn't break this apart into 2 fractions. I wouldn't do anything. Okay, so you're not solving this for entry into a computer, right? You're solving this for doing the problem by hand. So when you do this by hand, this is where you get. So this is fine. And so that's the quadratic formula. Now your other method would be complete the square. So in order to do that, actually, you know what? I lied. Completing the square doesn't work well on here. I'll explain why it doesn't, by the way. It's easy to see that it doesn't. So normally the way you complete the square is you take this middle term and you use it to calculate what I called the magic number. And the magic number was b over 2 squared. And if you do that here, the b is negative 3, which is odd. I mean, literally an odd number, not odd like weird. So you end up with this, negative 3 over 2. And we don't really like having fractions on these. So that's why I would say that completing the square is not the best way to do this. You can proceed, but like if you square this, you get 9 over 4. I should have rewritten my equation as x minus 3x equals 5. Basically just move this 5 back over to the other side. And then you could add the 9 over 4 to both sides. The 9 over 4 is the magic number. Add magic number, x minus 3x plus 9 over 4 equals 5 plus 9 over 4. See, the fractions just kind of make this look very ugly. Then you factor. Now, don't think too hard about how to factor. The way it's going to factor is it's always going to be x plus or minus something. And the something is always whatever this was, the negative 3 over 2. That's the number that's going to go here. The b over 2 is what ends up here. But if you don't know that, it'd be hard just to guess that. And that's why, again, I'm saying this is not a great method for this problem. That's a 3. And over here, you have 5 plus 9 over 4. I'll just do that on a calculator. 5 plus 9 over 4, 29 over 4. Notice that you're starting to see the 29, this 29 in here. And then if you were going to keep going, you would want to square root both sides because you're trying to get to the x. So you would end up with x minus 3 over 2 equals plus or minus square root 29 over 4. And then you would add 3 over 2 to both sides and end up with x equals 3 over 2 plus or minus square root 29 over 4. And this answer right here is the same as this answer over here if you look carefully, right? Like 3 over 2, 3, 2. Square root 29 over 4, well, square root 29 is there, and the bottom is square root 4, which is 2, which is that 2, 29 over 2. So these really are the same answer, but I mean, hopefully you can see that this was not the best way, but it did work. It did work. I would definitely use this method, quadratic formula. Okay, so those are solving quadratic equations. Now, finally, we're off to our last section. This is, I think this is section 2.5, by the way. And then down here, we're in last section, which is 2.7. Okay, and there's not a lot to these. You're just going to solve them the way you are on the homework, right now. So we're just going to solve these. Remember, the one special case scenario is when you multiply or divide by a negative. That will probably come up on the next problem. Anyway, so I wrote out my inequality. We're going to solve for x. So we're going to do what? Well, get the x's on one side. So minus 2x minus 2x. We have 5x minus 2x is 3x plus 2. And then negative 1. We're trying to get the x by itself. So I should minus 2 from both sides. 3x equals minus 3. No, not equals. Greater than or equals. And then I should divide both sides by 3. So over 3 over 3. And I get x greater than or equal to negative 1. Okay, that's my answer. Now, it's not my answer because I said write your answer in interval notation. So x greater than negative 1 on a number line, which was not asked for, but on a number line, greater than or equal to negative 1 is negative 1 this way, right? Which goes up to infinity. So the actual answer for x greater than negative 1 is negative 1 up to infinity, square bracket down there, parentheses there. The square bracket because this was greater than or equal. Up to positive infinity because out to the right forever is positive infinity. Okay. So that was kind of relatively easy one. Not the easiest because we had stuff on both sides of the equation, but easy enough. Let's move on to the next one. So this kind always trips people up. The putting these out of order is what trips people up. So the negative 7x here, right? You're not adding or subtracting 7, right? Because the 7's on the x. And what we want to do is we want to get rid of this 5 first by subtracting. So minus 5 minus 5. So we end up with negative 7x, right? Because that cancels. Less than 17 minus 5 is 12. And then we need to divide both sides by minus 7. So over minus 7 over minus 7. So on the left, minus 7x over minus 7 is just x. On the right, 12 over minus 7 is negative 12 over 7. The big thing to keep in mind here is that when you multiply or divide by a negative, the symbol flips direction. So when you multiply or divide by a negative, flip the symbol. So it's, instead of pointing to the left, it is going to point to the right, like that. That's your answer, x greater than or equal to negative 12 over 7, which in interval notation, like the previous problem, is going to be negative 12 over 7 up to infinity. Oops. Parentheses, parentheses. Right, parentheses this time because this does not have the equals on the bottom. However, it's still x greater, so it's still out to the right. All right. So that was how you solve an inequality. Next, we're moving on to absolute value equations, the last thing here. Now, the big thing about these absolute value equations is to remember that the direction of this symbol means a lot. So if it's this or this, you do one thing, and if it's this or this, you do another thing. So with that said, let's get started here. So we have x minus 5 less than or equal to 7. So in this case, for the symbol, the way it is, all you do is you drop off the absolute value like that, and you turn this into a compound inequality by adding this other side of the equation. So this symbol is this symbol, and whatever is here becomes negated. And then this is a compound inequality, and you solve the compound inequality, which is not that hard to do. We've got negative 7 less than or equal to x minus 5 less than or equal to 7. So we're trying to get x by itself. So we should do plus 5. On a compound inequality, there are 3 sides. So whatever you do in the middle, you have to do to all of the other sides as well. So we've got this. Let's see what we get. So we've got on the left, negative 7 plus 5 is negative 2, less than or equal. X minus 5 plus 5, those cancel, leaving just x. And then 7 plus 5 is going to be 12. Okay, so there's your answer. In interval notation, this is going to be x is between negative 2 and positive 12. So that's simply negative 2, positive 12. We've got the equals kind, so square brackets, square brackets. Done. Okay, last question. Now the last question here, again, now the symbol is the big deal. So you do not do this like we did the previous problem, because this is pointing in the opposite direction. It's a greater than. In this case, you go from 3x plus 1, in this case, greater than 7, and it splits up this way, not into a compound inequality. What you get is 2 separate inequalities. So 2 inequalities. One of them is going to be 3x plus 1 greater than 7. So that's just dropping these. This part looks like how we started this, right? Like we just dropped the absolute values to get this part. So that feels the same. However, we don't have another side of the equal sign here, not equal sign. We don't have another side to the inequality right here. What we have is an entire separate inequality. That is 3x plus 1. And what you do is this symbol needs to be reversed and the 7 needs to be negated. Okay, and we talked about y in class, and basically it was this. Whenever you have an absolute value greater than some number, what that looks like on the equation is like the 7's here, and we're saying this side. But we know that an absolute value could be positive or it could be negative, then you absolute value it and it makes it positive. What that means is anything over here would be greater than 7, but anything way over here would be like negative 10. After you absolute value it would also be greater than 7. So you get like a mirror image over here that goes the other way. So if this is a solution, this is also a solution. So like the mirror image is a solution. And that is why you have this greater than 7, less than negative 7 thing going on. Now, once you write your two inequalities, though, you just solve these like normal. So there's nothing to it. You just solve it the way you would. So minus 1, 3x less than negative 8, divide by 3, x less than negative 8 over 3. There's an answer. Or solve the other one. Minus 1, 3x greater than 7 minus 1 is going to be 6. We should divide both sides by 3. X greater than 6 over 3 is 2. So there's your other solution. Now, on a number line, which is not what we're asked to do, but if I put them on a number line, x greater than 2 is like over here, like that. And x less than negative 8/3, well, negative 8/3 is, somewhere on this side. And it's less than, so it's like this. Right? So your solution is actually in two different pieces, over here and over here, just like we showed up here. So left side and right side here. Now, in order to write that in interval notation, oh, what happened? Okay, we're back. In order to write that in interval notation, you have to know how to write each piece in interval notation, right? This one's 2 to infinity. This one over here is negative 8/3 down to negative infinity, like that. And then once you write these two individual intervals, we need to combine them into one interval to get your final answer. The way you do that is you write your two intervals. Technically doesn't matter which one you write first. Why does it keep doing that? Okay, we're back again. You write your first interval down. Union symbol, kind of is an ugly union symbol. Just redo that. And then 2 to infinity. So those are your two intervals, and then you just put a u in between them. And that's your answer. And the union just means combine this set and this set into one big set. Okay. So the key to this problem was knowing that using a greater than symbol here means you do one thing. Using a less than symbol means you do another thing. And so you got to know the difference. Okay, so I think that is it for the solutions to this practice test. Keep in mind what you're allowed to bring to the actual exam in terms of a cheat sheet and a calculator. And, ask any questions you have in class on Friday or Monday. All right, that's it for now. Talk to you guys later.